Thank you, everyone, for joining us today. Good morning, good afternoon, and good evening, everyone. Wherever you're joining us from, welcome, and thank you for being here today. On behalf of Retisoft, we're very excited to have organized this webinar for everyone here. Today's topic and further Q&A session is focused on understanding lab software and system selection for humans and robots. For those of you who don't know me, I'm Jeff Nagel, and I'll be your moderator for today. I'm a systems support engineer here at Retisoft. Just a little bit about me. I have close to 20 years experience in many engineering roles in the life science industry. I've held engineering roles with instrument vendors, as well as customer embedded engineering teams, and serving pharmaceutical and agricultural clients. And I'm very happy to bring my knowledge to my current role, educating customers on how they can maximize their lab's capabilities through software and hardware. A couple of housekeeping items before we get started. This webinar will end at 12 o'clock, followed by a 30-minute Q&A session. For all Q&A, all Q&A will be addressed at the end of the presentation. For questions, please click on the Q&A chat. Should you have a question that come to mind during the presentation, it's a good place to capture that. And when the time comes, if you simply want to raise your hand in a virtual reaction and ask your question live, that you can also do then there as well. Out of courtesy for our fellow participants, please remain muted at all times. We will monitor that should something slip up occasionally. It happens, but just for out of courtesy, we'll remain muted as possible. So this webinar is being recorded, and we will share this with all participants on this call. Our keynote speaker today will be Marc Caron. Marc has over 25 years of experience related to software development and delivery, and has led multiple teams throughout the life cycle development of software products. From software development management on the front end of the development cycle to customer-facing support team management, Marc is very knowledgeable on every aspect of software product delivery and deployment across many business sectors. Having served within the industrial manufacturing, electronic medical records, and nonprofit spaces, Marc understands that requirements are never a one-size-fits-all proposition, and it takes careful planning and collaboration with clients and internal partners to achieve a proper fit-for-purpose solution. So let's welcome Marc Caron to the call. Welcome, Marc. How are you doing today?
Thanks, Jeff. I'm doing good. How are you?
I'm doing well. Thank you for asking. Well, on behalf of Retisoft, let me just say we're very pleased to have you here providing all of us such valuable information and industry insight. And with that, Marc, feel free to take it away.
All right. Well, thank you very much, Jeff. And with that, yeah, let's dive right in. So today we're going to talk about various aspects of tracking data in a lab, but more than just experiments being run, which is where most of the focus usually resides, but also the supporting aspects that help ensure the accuracy and timeliness of experiments run. So an important question I want you to keep in mind through the entire process, because it weighs heavily on how software and hardware can help you with your lab management. And that is, what's the purpose of your lab? Keep in mind, some combinations of these options work. Some are more trouble than they are worth. Maybe you need multiple labs and systems for a better return on investment instead of trying to fill all the needs with one solution. And you may also be doing it, just for fun. Maybe you just want to play with automation or try a new system just for fun. That's also an option. But many of these things still apply just to actually keep it functional instead of just being a nuisance. So now that you have some vision of why your lab exists and what you're trying to do, let's talk about the LIMS systems. So LIMS with a little I. So we'll go back to the I in a minute, but here's the Wikipedia's definition of a LIMS. In reality, it's kind of a nebulous software area with many vendors pushing the bounds of functionality But with that often comes a fair amount of vaporware, a feature to check a box on a request for proposal that can barely claim to fill the functionality. I've personally seen that from vendors I've worked with and companies I've done work for. It's not just a LIMS problem, but kind of a commercial software problem in general. So you must always validate the features accomplish the task for your version of whatever that need is. But at its most basic, when tracking in a lab, things happen. And that includes planning, organizing, could even include staff management. But every time something happens, information is created. Information just happens. It just manifests when something happens. Now there's tracking of what has happened. All of that information matters, is the catch. And this is why a little I, because LIMS can only see a small fraction of that information that is actually valid and important in any kind of a lab setting. So what's missing? So what kind of things do we need to track in a lab? Let's start there. Here are some. We've got more, but here's an initial starting list of things you might want to track in a lab. Not going to go over every item. And what is most important to your lab is dependent on your focus and needs of that lab. So let's talk about logistics as an example. What volume of consumables do you normally use a month? What's the lead time on ordering? What's the planned consumption of those consumables during the current lead time or the next lead time? How much do you currently have on hand? You can just over order all the time, and that's an option, but it still doesn't mean you won't run out. More things that need tracked in a lab. Take regulation. If you're dealing with medical, everyone knows of HIPAA. So it's important to be able to know who has had access, who has viewed information, and be able to prove that, especially when there is personally identifiable information involved with the information tracked by your LIMS or anything in your lab. The reality here is there are many things that go into managing a lab, and those are just a couple very quick examples. But it all comes down to tracking what's going through your lab, knowing what's going on, and being able to ensure you are providing proper results, valid results, provable results within the available timeframes that you need those results. So what about some stuff that LIMS has a hard time with? So LIMS historically designed to track the experiment. That was its original purpose, and manually track that experiment. But now, as we discussed, there's many logistical factors that go on with that we need some insights to ensure we can have an effective and efficient lab. So here are a few things that I've personally had conversations with groups about that they wanted to see that weren't handled by their existing systems. And in reality, the LIMS shouldn't be responsible for many of these things, as there are dedicated products or even full industries to manage some of these needs. Inventory is a great example. There are a ton of inventory systems out there. I have seen companies build many different inventory systems, each special tailored to a specific lab or purpose. But each system is doing 98% the exact same thing. So now you're managing 5 systems that do the same thing, but each one does it actually differently. And so they can't talk to each other even. Some more things that can't easily be tracked. Auditing is a great example. So all the tools, whether it be inventory or automation, whatever, they create logs of what has happened. And there's a need to see that information across a total view of the lab, not just to an individual application. And there are many tools to accomplish that now. And we'll dig a little more into that later, but it's the functionality's there, but not in a human consumable way is part of the issue you run into with something like that. So that's a very, very quick, high level view of what does a LIMS track, what can't it track, or doesn't track well. So now we'll do a quick view of things to keep in mind as we're also talking about automation. So second question to keep in mind as we go from the initial just what are you doing with your lab to now you want to add some automation of why do you want to add some automation. You'll notice some similarities to what you had for what's the lab's purpose, but it's definitely not a one-to-one. And you could easily have, say, a discovery lab that happens to do thousands of iterations of a standard process daily, but it's for discovery purposes, not a production certified lab. And so in that case, you're still building for consistency and volume, but not necessarily for compliance. And what is the consistency you need for that discovery versus what you might need for that same test when it comes to compliance. So there are aspects you need to look at that they're just slight nuances on the same topic, but they weigh heavily when trying to decide how to accomplish the automation and to what level you need it. And a very important thing to keep in mind when adding any kind of automation is that why is for humans. So step one with automation, understand robots currently are dumb. I mean, they can do only what we tell them to. And you might say, oh, but robots can make choices. Oh, yeah, they can. Vision systems, as an example, can detect anomalies of parts going by. They can flip a gate when a number of things have gone by. They can see a color on one item is different than others and throw that item away. So those are choices, but they are very strict choices that the robot has been explicitly instructed to do, and they are predetermined on how to make that choice. So in order to do that, though, it's necessary to break things down to their most basic parts for instructing the automation. So we do what's called process isolation, or in very basic terms, they are breaking larger things into smaller parts. But step one of adding automation to anything, or honestly, even adding a new software system, is that you have to accept that your process is going to change. It's important to understand why each step is being done. Often, something's in the mix because of prior constraints from software that doesn't apply anymore, or someone just happened to do it that way and then they trained everyone else. Or maybe this was a pre-step that was originally for a different end reason and needed an extra step in its small portion, but you don't need that anymore. You're just doing the first part of that smaller task. So any number of reasons, but the key is we need to look at each of them and make sure that we're doing them for intentional reasons, not just because we've always done it that way, which is probably the most common answer when asked why something's done this way. So next, we need to isolate each task. And so a very simple example of this is you're in a doctor's office and you're collecting blood pressure. Well, that's a very singular thing. You don't have to do anything else. You can do it with other stuff, but it is its own singular task. And you also don't care, is it captured by a human with a stethoscope, or is it captured with an automated cuff? And do you care why it's captured either way? Do you care if it's captured with other vitals or on its own? No, you just care that the blood pressure was captured, but you do care of when it was captured and the how that was used to capture it, because that how is now part of the data of that blood pressure, not just the final blood pressure value. And so then there are many things done in a lab that are a series of 2, 3, 5, whatever individual of these little tasks that we've broken things down to. And these are small processes that are often done in many larger workflows. And it's easier to find them as their own sub-process and then use that sub-process over and over in the larger flows. An example, again, sticking with the doctor's office, you're collecting blood pressure. You're also collecting other vitals, temperature, height, respirations per minute. It's done pretty much for every visit. Not necessarily. Maybe you don't do respirations every time. But the idea is that collecting of vitals is actually a collection of multiple smaller tasks that in this case, though, don't necessarily need to be done in a sequential order either. So often doing this turns your larger flows then into just a linear series of these smaller sub-processes. This is really important because it helps ease maintenance of any software or hardware systems by limiting how many permutations of process you're actually dealing with. If I actually had the vitals listed as a sequential process, and sometimes I cared what order they were done in, right there, I've got multiple variations of just a simple 4-step process. Well, which one do I need? If I need to change how blood pressure is done somewhere, which of those sub-processes is used? Or if I change blood pressure itself, now I need to go change force, all of the permutations of that sub-process that are being used by other systems. It snowballs the complexity if you do every larger workflow as the most minuscule tasks throughout. Which also then gives us option at this point to reimagine. Don't be ingrained with the status quo. Take the opportunity to kind of dream big. Look at things in new light. Some things are way easier than they seem. At the same time, some things are seemingly really easy and actually end up being really hard to do, at least with automation or simple at a task level. But it doesn't hurt to bring up the ideas, no matter how crazy they may seem, because if you don't bring it up, then there will never be discussion to look at that task and reevaluate the hows and whys of what is being done currently. But you also have to remember things are not infinitely flexible. You're trying to create standard and simple processes or tasks, combinations of simple tasks, not give the user thousands of options or choices at every task, because then it would be no longer simple or consistent, and people like to turn knobs, and that will then ultimately not give you consistent data in the end, and there'll be too many variables you need to look at just to know what is this information. Another big reason for keeping things simple at that task level and then building up sub-processes in your larger workflows is it really helps with testing. When things are simplified to those individual tasks, you can walk down to that one item, validate that task with whatever new method's being done. You know that task works. Now you know it works in the sub-processes it's in and within the larger flows without having to necessarily reevaluate every large process you have. Do keep in mind, though, small changes can have really big unforeseen effects. Again, automation only does the task it's given the way it's designed, but there are details that will throw it off. A good example being, I saw data matrix tubes, just standard 96 well plates, and someone bought a new vendor's worth, and they just ordered buckets of them. So all of a sudden they're using these new tubes that had a 30% failure rate on reading that barcode. There are a ton of aspects that go into some of these little things, like reading the bottom of a tube. You've got all your lens physics or refraction physics, lighting, that's all before you can take the basic picture. So what's your camera like before you are then passing it off to software to interpret it when you're dealing with a whole plate of them. It's some of these things are, like I said, far more complex than they seem. And so it's important to test those little changes to make sure that that doesn't happen to be the little change that blows up the item. So that said, with all these pieces, as you break things down to tasks, we want to fill in some of these holes across the information tracking. So how do we deal with the larger limbs ecosystem? Now that we've broken things into our smaller tasks, we have tools for every job. And it's important to use the proper tool for every job. So look at your full ecosystem from a business and lab standpoint, not just the lab process standpoint. How things get in and out of the lab as well. Those handoffs often dictate how things happen in the lab as well. But again, it's just at this larger level, as we're looking at the entire LIMS ecosystem, we are still isolating tasks, but this time we're isolating large tasks. So inventory, reporting, process management, whatever. These are the large buckets that we want to select specific tools to accomplish. Be clear on what your needs are for each area, especially by company function. So like a CFO wants to see very different information than your lab manager or support tech for the exact same space in the company, whether it be a lab, a specific process, or whatever. It is important when selecting tools to keep focused on the primary purpose of that tool. So what is that big task? Don't stray into other nice to haves. Nothing else matters when you're looking at that primary thing. So if you're looking at an inventory solution as an example, a lot of them will have connectors for scanning and all sorts of things. But if the basic inventory doesn't accomplish your needs for inventory, then it doesn't matter what other bells and whistles it has. That's where we move to interaction. So since we're looking at a lot more tools than just the one LIMS system, it becomes increasingly important to select tools that are designed to live in a shared ecosystem with other products. So gone are the days of one tool to do everything. So if a tool isn't designed with clear APIs and the ability to trigger to or from other systems, it's likely not very long for this world anymore. Because that is the need when you are dealing with multiple tools. They have to be able to talk with each other. And you don't want to have to custom build a bunch of stuff if you can avoid it within that process. So if they don't already have the exposed mechanisms, you don't want to be in the business of building them. So while the results of the experiment are ultimately the data we care about, there are thousands of other data points going on in the process as well that can affect those results. So as it is, the scientific process dictates that the process of how you achieve those results is part of the results. It's part of that proof and validation. So this particular section, specifically taking a page out of cloud and infrastructure monitoring management. In the past, it's always been hard to get real data on the health of systems, PCs, printers, storage, network, whatever, when you're talking about a large corporation. But as more things have become distributed for cloud hosting, this has become more mainstream to have a consolidated view of all of those moving parts. And there is much more tooling now than there ever has been before to allow for that viewing. So it allows dashboarding, real-time reporting, as well as anomaly detection and other aspects of what is deviating from the norm within this space, because that's part of dashboarding, is something sticks out. When you see real-time data going by, an anomaly will stick out. It can also dynamically find those and alert on them. All of this does add complexity. Multiple systems talking together is more complex than a single system. But the intended is to provide a better experience for the user on the front end, even though it does add more complexities on the back end. But also in reality, when you're dealing with forcing a tool to do something that it is not good at, versus integrating a second tool that is designed to do that secondary purpose, it's often much easier to maintain long term as well. So, cloud versus local is always a big question. And it's very flexible now. It is a very open question at this point. Not everything needs to be on premise, and not everything needs to be cloud based. Now, there are trade-offs for both options, and these are also there are also dependencies in staffing, redundancies of networking, or hardware systems, accessibility, depending on where you are, things like that. But the point being is a mixture is okay. It's just necessary to understand the needs and purpose of the tooling selected for each of the parts, and what goes into making them work together. And then, of course, everyone's favorite topic is always the cost. So, everything you do has a cost. So the choices above will factor into how much can you spend? What are your options based off how much can you spend? How much does it cost for an outage, though, or lost samples? Are they recoverable or not if the hardware does go down? It's not just the cost of buying the software or hardware up front, especially as you mix in cloud options, which are usually a subscription model monthly by use, but the cost of daily doing business and keeping things running as well. So that's your recurring charges, subscriptions, staff to maintain it, extra hardware if necessary for immediate swap out. There are a lot that goes into making sure that if there is a problem, you can recover from it within a reasonable amount of time that is within your willingness of loss, is what that comes down to. And that is a very business specific question. So now we'll talk a little more about adding the automation into the environment. And they are there to help us. I've experienced from people over the years, automation, whether it be software automation or hardware automation, a lot of people tend to have anxiety over it. But it's very important to understand and keep in mind that the automation is there to help the humans with mundane, repetitive tasks. It is not there to replace thinking humans. The thinking humans are there to instruct the robot, basically. The robots are not there to take over. And so another big thing too, though, is it's not an either or. It doesn't have to be an all manual or an all automated. You can have clean combinations of both. But that goes back to, why are you automating? High volumes likely to be fully hands off, whereas discovery is more of an assistance and interaction. If you're somewhere in the middle, you might have some of both. It does add, again, more complexities. But if you approach it from the basic tasks and sub-processes, it helps remove some of those complexities that have been introduced over time, and gives you a easier handoff to and from the hardware. And visibility, whether it's humans doing the work or robots, irrelevant. The visibility of what has been done, what needs done, what are our results, all of these things still need done. And so the reporting and dashboarding is still hugely important, just to track the volume of information going on. And keep in mind, it is more about helping track the process as opposed to monitoring, making sure people are doing their work. It is to make sure that the ecosystem is healthy. And also, as someone in the ecosystem, you have an idea of what's going on. So again, back to the process isolation, part of the reason for it is that easy stepping to and from humans to autonomous actions. There are very clear lines of inputs and outputs of each process. End result doesn't matter if it was executed by a human or a robot, just that the proper procedures were followed, the results are accurate, and you're able to validate and see that the things were done as intended, to validate those results and make those results then available for future steps. So back to the anxiety things. Yeah, humans are here to tell robots what to do. Without humans here to tell the robots what to do, they are going to sit there and be paperweights right now. The majority of your lab automation really will do nothing if you aren't there to tell it what to do. And the idea is that the humans are there to think. There's always more problems to solve, more information to figure out. The more data available, the more good data available, the more humans are able then to work with it and create new solutions, come up with new ideas, spend less time fixing data or hunting down missing data. That's part of the purpose of all of these parts, is it builds better data sets to validate and allow for future discovery. So all that said, there is no golden hammer. So the golden hammer is an anti-pattern in software development. Basically, it says the idea of the golden hammer is there's one tool to do everything. And usually it's referring to a developer that has learned something new and they go and apply it to everything because it's new and cool and it'll fix all the things. But it's based off if I have a hammer, everything looks like a nail. Problem is that approach ensures nothing works well. You're constantly finding workarounds to get the result, to use your one tool to do it. The problem is this is what I've also seen companies do, because they will take their one limb system and they will find a way to mash every problem into it. So then they customize it beyond its intended customization level. Now you can't leave that system. Migrations or even upgrades of that existing system then become cost prohibitive and you are stuck on a system that you can't move forward with. A key feature of all of this approach is ensuring that every section is able to be upgraded and migrated forward, and not just stuck and stagnant. As soon as something becomes stuck and stagnant and you can't upgrade it, it will hold your lab and process behind because no one will dare spend the money. If you can continually be upgrading the different sections independent of each other, it's much easier to keep up to date with new functionality and features that become available in the industry. So with that said, I hope you found this informative. Again, my name is Mark. I am the owner of Vote Platypus. There's a story with the name, but it doesn't really matter. But generally, we specialize in guiding companies to figure out what fits them, what is their need, and what tools are best suited for them, whether it's off the shelf, custom, whatever. It is about providing solutions that meet a business need so they can do their work. And with that, I will hand it back over to Jeff.
All right. Thank you, Mark. That's a great presentation. You really did provide us with a lot of great things to consider when it comes to taking lab operations, at least to that next level. One of the things I found most interesting was your connection between everything within the process is connected to the data pipeline. It's not just the end product of that data that you're always looking for, which is how do I fill my pipeline of products? It's more of like, hey, if I can duplicate this process as a whole, I need to know how to do that. And it typically doesn't seem to get recorded, but it is very important. So maybe some questions will come up about that. We'll see. Before we start with the Q&A, I wanted to quickly share with everyone, since we're on this slide, a little bit about Retisoft. So Retisoft is a software and hardware integration company with 24 years experience as of tomorrow. So happy birthday, Retisoft. And they are focused on the life science industry exclusively. As research companies do approach the concept of implementing automation, just like Mark had mentioned, for their scientific processes. We have a tendency to work with many of the concepts that Mark covered in this webinar. For instance, process isolation, and then proper equipment selection. Always important when you break these things down, that will now determine which instruments are the proper fit for purpose. So as we collaborate with our integration partners, our instrument vendors, again, hitting API documentation that Mark had mentioned earlier, and our customers, anyone else on this call, we take pride in knowing that the solution that we provide fits your laboratory needs now and into the future. So if you would like to contact us to discuss your automation needs, please visit us at www.retisoft.com and explore all the services we have to offer. If I also would like to extend an invitation to everyone here today to a live group demo with me, yours truly, where you can learn more about Genera, our automation flagship software product, knowing how it works and see if Genera is a good fit for you. So please scan the code on the screen to save your spot, or you can click the link that will be provided in the chat so you can go straight to the page. So Mark, I do have a question for you.
Mm-hmm.
Are you ready to answer some questions? Is the question.
I am. Let's answer some questions.
All right. So here's one. So what are your thoughts on custom limbs versus off-the-shelf limbs products?
So that is one. It is dependent on size of company and need in many ways from what I have seen. They work well for a lab, for a few processes. I've seen them, they're designed to be customized. And so I have seen them customized to where they are no longer maintainable and no one actually knows what's going on anymore. And that is always the danger, is you lose that visibility. And even if you use an off-the-shelf engine, how do you get that visibility? You still need to tie in some of the other tooling to enable that. Custom limbs can be great. I have also been part of building those. And it becomes, is there something reasonably cost that fits the need, especially if it's a simple process for just one lab kind of thing? Maybe that's a cheaper option to do something customized. And it also comes down to what do you have for staff to maintain it? If you don't have dedicated IT staff, programmers, people to help manage all of this, then running your own or building your own has complications past just standing up an application and making sure it's backed up. And if you don't have staff on hand for that, what's your downtime again? If there is a problem and you used an outsourced company, that company or the specific contractors that worked on it, if you don't have staff, have never touched that system, how long is it going to take them to get up to speed to be able to work on it? And I've seen that even within large companies too, though, custom limbs where the people that all worked on it are gone and it hasn't been touched in 5-6 years. So if you are going to do custom limbs, treat it like a living, breathing thing. Make sure it is regularly being at least touched, refreshed. You want to upgrade libraries and stuff from a security standpoint. If you are using a off-the-shelf limbs, ensure you are keeping it patched and up to date, and not making customizations that prevent you moving forward to new versions of that limbs. Those would be the biggest things to watch out for either side.
Okay. All right. So here's another one. In your experiences, have R&D management, I think this goes to the overall data of the workflow itself, not just the end product data. Have they taken an active interest in wanting to know every type of data within their operation and not just the end data product from scientific experiments? Have you, I mean, in the experiences that you've had, has that been something where management's like, we need to know more about our quote unquote operation and not just the science at the end of it?
I have seen both sides of that. I have had to fight tooth and nail to get people to understand it's important. And and been told explicitly, actually, before that the process doesn't matter. All we care about is the science, which I find to be a silly statement. But also, I have more recently, over the last probably 5 years, groups are far more open to being able to see that information of the process in between. And actually, to put it in a very simple perspective, as far as the process in between, um, recently talking with a friend who bought an automated donut maker, essentially, where you throw in all the ingredients. It takes care of mixing it, rising it, rolling it, cutting it, frying it. Donuts, cool. Within that process, you still have many things you want to know throughout. What is the temperature of the oil before the donuts are tossed in? What is it after they come out? What's the normal deviation? Is there a change in time on how long it's taking for the dough to be rolled and cut? How many failures are there on the cuts? When you're dealing with proofing the dough, what is the temperature around in the environment that is proofing in to control how long it's left to proof? So all these things, they are part of the process. They are little capture points. But every step of that process and when it was done helps give you a very clear view of your end result, as opposed to just, hey, look, a donut.
The donuts are good. Everyone
Donuts are
loves
good.
donuts. So there's another one here that talks about, and you did hit on this, from the cloud-based to an on-prem solution for software in general. So there seems to be a growing trend, and we all know that the word cloud is big, right? We interact with it daily in our lives, and we just don't even recognize it. So what are your thoughts on cloud-based software as it relates to, in this specific context, automation instrument control? Not limbs, but instrument control.
So for instrument control specifically, first questions become, what happens when you have downtime in your lab? So as a result of some of the automation breaks, okay, that's one thing. But what if your control software can no longer talk to the automation? And what is the effort to get it back in sync should that happen? Is there a time involved or not to ensure the automation software now knows the state of every hardware device and can pick up where it left off? And I mention that because when you are dealing with, I have stuff locally on premise, talking with things in the cloud, your network connection is very much your weakest link in that. So do you have networking staff on hand to ensure that you can have redundant connections to the internet, which is a little more complex on your network switching gear and how you configure that? There are also then latencies of how long it takes the automation to talk to the cloud. Does that matter in your scenario? It is a viable option, and it certainly helps with all of the hardware hosting aspects of the control software, but it complicates your network. You still need power redundancy on your automation, and you still need to understand the impacts that will be had should your connection go down, because that's still possible. Your connection to the internet will go down. And if you're doing on premise, though, your other complications are, what is your redundancy of the machine running the control software? Maybe you need a second machine sitting around just in case. You still need your power backup. You still need you still want some redundancies in networking. It's not an either or, but it's a different, now you're talking more server management and data backup management and everything versus just networking if you're doing on premise. So the skills you need to support it, slightly different, but there's some overlap. And so a lot of it will come down to, what do you have and what is the norm that your company is managing as well?
Right. Okay. Yeah, there's also probably some elements of new versions when you're talking about on-prem and new features that may not get deployed because it's not part of a cloud-based solution.
Well, and so that's something actually with the cloud-based solutions is depends on how it's hosted. If it's purely a SaaS solution where they're maintaining it, updates happen automatically. You don't get a choice necessarily. Is that okay for you? On premise, you have to plan those upgrades and stuff. And again, you still have to be able to recover if there is an issue on updating.
Okay. So we have a question from Robert Glenn. What are some of the rules of thumb to follow in deciding if the LIMS is getting too customized? When do you say enough's enough?
Certainly, if you are running into bugs of the system, that's usually an indication you're pushing it a little too far. If you have, I have a friend dealing with this currently. You have scripts that no one knows what they do involved in part of the ecosystem. You have 5 copies of the same thing that are, well, they might be named different, but they're the same configuration. A lot of it comes down to how you maintain it, and do you actually understand the customizations that have been done, and can you easily audit them, and rip out ones no longer needed. So you really are moving into kind of a source code management in many ways approach to how to deal with that. And some of this goes back to how big's your lab. If most likely, if one person or 2 people can't kind of know the full breadth of everything going on with that system and customizations, you probably have gone a little too far, and maybe need to back off a little. But again, that's going to be somewhat dependent on size of corporation and infrastructure to support. If you get 100 people in the lab, okay, that's probably way too small of a number of people to be able to wrap their head around it. But as you grow bigger with your customizations, just like any kind of software project, the amount of communication you need to do between all the individuals to stay in sync and ensure there's a full view understanding of what's going on, that's going to be your barrier.
Okay. We have another one here from a gentleman named Luis. What are some of the most common mistakes startups make when selecting a LIMS? Perhaps overlooked or just simple naive mistakes?
Solid question. I have not done LIMS with a startup, but from what I've seen in large corporations, I imagine it's probably the same. Just naive believing what they're being told it'll do without validating it is usually one of the biggest things. Or assuming it will solve all your problems without need for some of the other tools still, especially the reporting and dedicated tooling to run your automation, probably being 2 of the bigger ones, I would think.
Okay. Just looking through, seeing if there are any others. Not seeing any more on the chat. Any other questions that someone might have?
One I'll mention that I know has come up in the past is people asking about AI in lab management systems. And while I've not directly worked on any of that, I've done some looking to see what's out there. And everything I can find is essentially based off the log analytics and reporting. So using the tooling that exists in the log and metrics, alerting and monitoring software to detect anomalies and let you know about that, or let you know of service times based off volume of samples through a device or something. That's mostly what I've seen, and AI being one of the most misunderstood things anyway, because most of it is just machine learning and anomaly detection versus actual inference of what's going on.
Okay. All right. Well, that's all the questions we have. So what I'd like to do is I think we can wrap up here. We'll be quite a bit early, but I really, again, on behalf of Retisoft and behalf of Mark, we really appreciate all the attendees coming today. And we hope that you enjoyed it and got a lot of information. And our moderators, back-end moderators, will be sending this presentation back out to you. So everyone can refer back to this, and we hope the rest of you, all of you, have a wonderful rest of your day, whatever's left of it. Thank you, everyone.
Thank you very much, Jeff.
All right, take care.